Okay, cool. Now what are some places to start? Yeah. I'm not just going to work through it.
Number 1.
It's not how we're going to do this. What are you talking about?
Number 11, that like f of g of 2 and g of f of 2.
Okay, cool. Those like starting with E through G?
Yeah.
All right, let's do that. All right, hop down to number 11. If you don't have your review, I have paper up here. I brought a bunch of notebook paper if you want it. This is posted already, so as soon as we press save, it'll get posted again. So as you're looking tonight and you're trying to study, you can watch this video. I'll try to upload the video in between classes so it's done quickly and just give you as much as you can to study for the next 2 days. All right, so you're talking about, you're okay with the plussing and the minusing and the timesing and everything?
Yeah.
But you're talking about finding, this has a name. I know you don't, what? It is? Sweet. So every time I press save, it should update, so you should be good to go. This has a name. You probably don't need to know the name, but while we're here, it's worth talking about. Oh, no. Starts with a C.
Composition.
It is composition. Sweet. This is a composition. Okay. Now, instead of answering your question, I'm going to ask you a different question. Is how easy is this problem if it would have just said this? Zoom in real big. Pretend like this isn't here. Could you have answered this question?
Yeah.
Well, okay.
Minus 3 is negative 1. Oh, negative 1.
Okay. Okay. That's the red problem. Okay? So what you've told me is that g of 2 equals negative 1. So what happens to that g of 2?
What goes inside?
What goes inside?
The x's?
Call this the red square, right? And now we're actually looking for f of g of 2. But what gets red squared out of all that stuff? F of... What? Yeah, because g of 2 is just negative 1, right? You see what I'm saying there? Or maybe it'd be better if we wrote it one extra step. F of g of 2. Hey-oh. Oh, that was fun. Which is the same thing as f of negative 1 based on our red square right above, right? Okay. And now how easy is that question? We'll call that the blue one. F of negative 1 is... Do we just go and plug it in? Negative 1 squared plus negative 1 plus 1. Probably something like 1. What? Yeah. Well, no, was it posted? No. Is it now? Yes. It was from last year, and I forgot to redo it this year. But it was up on last year's. I just didn't realize I hadn't re-upped it. But now it is, and it also, it's not only posted, but like completed is posted too. So I should do that every time. I didn't know that was a thing until I learned that yesterday. Then I can just like press this save button if I save it in the right spot, and it updates the right column as well. Okay, here's a question though, because I've seen people miss this one, even though it shouldn't take too long to cover. What does D technically mean?
You know what? I have no idea.
Exactly. Exactly. I have no idea. They're multiplied. What does this little O looking thing mean? It means of, right? So this is the exact same thing as what we just did, but g of f of x. So if you see that O, think the word of. G of f of x.
Can we do that one too?
What's the same thing as what we just did?
I don't get it. There's no numbers.
Oh, when there's no numbers? That's fair. We can. Okay. So let me go over here. Just for space. G of f. Whoops. G of f of x. All right. Let's turn f of x into a different color. So g of f of x was blue before, right?
Yeah.
Okay. So what is the blue function? Yeah. You go just pull the whole function. It looks like x squared plus x plus 1. Is that what it says up above? Okay. Now here is where it gets a little dicey for most people. Is you would know exactly what to do. You would literally know exactly what to do. And you did, oh, we did already. Holy crap. Look. What did you do with that 2? You just plugged it in. So what are you going to do with this x squared plus x plus 1? Plug it into where? Absolutely. And if you don't like that, do like a big square around it, right? See this square right here? That square is going to do all the work for us. So instead of plugging it in, I'm going to plug in that square, and then I'm going to write that square in. So what is g of x? Okay, I'm not going to write x minus 3. What I'm going to do is I'm going to write square or rectangle minus 3, right? And now what goes in that rectangle? Absolutely.
And you wanted to put it in parentheses always.
This one wouldn't have to be in parentheses, no. But
Would you subtract?
I do it to be safe just in case it had a negative sign in front of it. I always do it just to be safe. Yeah, then we could go ahead and subtract the two like terms. There's only two alike terms. X squared plus x minus 2. That is, was that g? No, that was g of f of x. There's two compositions. Zoom out. Save. Updated. That is composing two functions. That's taking a function of a function. Taking a function, putting it inside another function, plugging it in everywhere you see an x.
You do G.
Fine. I knew it. I literally knew that. So what does this say then? This says g of g of g. This is just technically what it means. Mathematically what it means is g, big old parentheses, g, big old parentheses, g. Close it up. You know what goes inside of the third one? Mm-hmm. And then how many parentheses do we need to close it? One at a time. What is g of x, green style?
X minus 3.
G of a green, x minus 3. Everybody cool with that? Okay. Blue time. Ooh, this does get dicey. What do we do with the green? We take the green stuff and we plug it in to everywhere we were going to see an x, right? So x minus 3 minus 3. Because wasn't this technically up here the blue x that it got plugged into? And then we probably need one more color, even though it's not pretty. I know it's not pretty. Wait, actually, no. I made a really big mistake here. What's the really big mistake I just made? And we'll look at this because it's so easy to let happen. Yes, we can do that, but not yet. Okay, that's combining like terms. That we can definitely do that, but yes. As I was rewriting slowly, I missed something that should still be there.
The brackets?
There's still one G. Whoa. Well, that's going to suck for the whole day.
Oh, because G.
This is the blue thing, right? This is what I underlined in blue. There still should be a G left, right? And we knew because we were about to have to do it. But it's good to write it every time. And this would be the last minus 3. So it's going to be x minus 3 minus 3 minus 3. Just keep getting tacked on at the end. No. Look, it looks like it's just the function inside of the same function inside of the same function. Here's your green function. Here's your blue function. Here's your red function.
But I don't get it. Like, I thought you multiplied one more time with x minus 3.
Did I do too many?
No, there's 3.
What do you mean? What do you mean by multiply one more time?
Because I thought x,
Mm-hmm.
g,
Mm-hmm.
parentheses x minus 3.
Mm-hmm.
If I have another g, do I multiply it 2 times?
Okay, so that's a really important thought. This is not multiplication. This right here is not f times 2. And we did talk about this for a long time because I talked about like my freaking third grade.
I'm not.
Oh, okay.
So the g,
Uh-huh.
I thought. So first I get g minus 3 is 1.
Where'd you get g minus 3 from?
Not g.
Oh.
G, parentheses x minus 3.
This one right here.
Yes. And you said that another g. I thought you supposed to do another x minus 3.
That we did. It's right there.
Oh, you bring the 3 outside.
Yes.
What happened to the x then?
No, that is a good thought. Okay, yeah, I know. Hang on, let's think.
Wait, what?
Nothing. It's just like, why is there only one x when we technically did the function 3 times?
Because you're plugging.
Because they're using the same variable to plug into the same variable. As mean as that is of them to do, here's a different way you can look at it, which maybe is a little better. G of G of G, and we're going to write the x. But now don't ever think of G as G of x anymore in your brain. Think of G as like G of square. Now this is going to help a little bit, because what is G of square then? I don't remember the function.
X minus 3.
Don't know. What's G of square? Thank you. And it's technically not a square. It's a thing we're going to write inside of. Square minus 3, right? Okay, so now, what's this green thing technically?
X minus 3.
No, the green thing. The green thing would be
The first one.
x minus 3, right? Okay, let's plug that into this. Let's take that x minus 3. And what's the blue thing?
X minus 3.
All of that minus 3. Okay, and what's the red thing?
All of that minus 3.
All of that. And that's why you only got one x, even though you wanted a lot of x's. It's because now I'm not thinking of this function as x's. I'm thinking of it as empty blanks where we're going to plug stuff in. That is a really good picture, actually. Even though it looks not pretty, that squared picture right there is a really good picture for what's happening. It's like a kaleidoscoping exact same function. With the easiest one being this right here. You don't need that green square. It's worth having, actually, because then you can see. That's where the x is disappearing to. There's no second and third x because the whole thing is taking the place of the second and third x. Technically, this was your third x right here, this red square. And technically, this blue square is your second x. And technically, this green square was your third x, but guess what? It's just x because that was our insidest thing of the green. There's no more g to plug in or f to plug in or anything.
So technically, we should always have one x.
On the very, very inside. No, but sometimes two. You might have two, because what if g of x was x squared plus x? Now you'd have 2 on the inside. No. You just have 2 on... Yeah, you would have to do 2 different blanks.
When we write out our answer, do you want us to put like G of G of...
Yeah, or anyway, really. I don't mind.
It doesn't matter.
It doesn't matter. You could put the first thing, the second thing. There's some other people... Yeah, it's fine.
Wait, so for the addition and subtraction, we just have the function.
Oh, no. You could write it like that and leave it, or you know what else you could write? X minus 9. Call it a day.
Oh, yeah.
X minus 3 minus 3 minus 3 is just minus 9, right? If I steal 3 cookies from you, then steal another 3, then steal another 3.
You're left with 9.
Wait, but is it...
And if you don't like that, if you don't like it, here's what you can do, is plug in a number and see if your function was right. Plug in a number, see if your function was right. Like plug in 1. What's g of 1? One minus 3 is negative 2. Plug in negative 2. What's g of negative 2? Negative 5. Plug in negative 5. What's negative 5? Negative 8. All right, now if you do that function, if you steal 3 things 3 times, I guess 1 was a bad number. 10 would have been an easier number to pick. But if you do this function to 10, like what's g of 10? It's probably 7. What's g of 7?
4.
What's g of 4?
1.
Okay, so that's doing the function 3 times, right? Well, let's go plug 10 into our new function. Where's our new function? Right there. What's g of 10? Oh, cool. It worked out. Our function was probably right. That's just like a small check. All right, let's not waste too much time on composition. There's so many other things.
May I ask one question?
Sure.
When you're adding
Mm-hmm.
like f plus g, would
Mhm.
you just would you just put 1 in brackets? What, like if
I would put both in brackets.
Oh,
But combine like terms. You have to combine like terms, right?
yeah.
So you would combine the x and the 3 and the 1. Like 2x and negative 2. X squared stays by itself. Okay. Let's move. Let's get something else. We can come back to it if we have time. And if the other class asks the same question, you can go back and watch the video and I'll explain it a little bit differently. But there's so many problems. 16 is pretty good. You should have definitely looked at this before today. You got it like a week ago.
I have another question, but I don't want to keep asking it.
On that same topic?
No, on a different.
Yeah, no, ask it. So you're not the only person with questions.
For 14.
Cool. 14. Ooh, inverses are good, and this is a hard one. This is the hard type where I said, I promise this probably won't be on the final, but it does look like it's rearing its head on the first test. So this is the hardest type of inverse. It'll never get harder than this in terms of inverses, but I won't lie to you and say this is like the normal inverses, like when it's not a fraction, are way better.
Right.
This is ugly.
I'm bad at fractions.
Yeah, everybody, not just you. Most people are. Okay, so we have. I don't need to rewrite it. Step 1 for inverses.
Well, why?
Step 1's a really easy step that I don't even know why it's a step. Y equals.
14.
Thank you. Question number 14 if you're watching a video. Okay. Step 2.
Switch.
Whoa.
Switch Y and X.
Oh, do you want to do that? We can do that first. You can switch steps 2 and 3. They don't matter which way. That's going to make our lives a little bit better, but not. Yeah, so X equals. Now we're just mixing up everything. But so then what is step 3 probably? Sure. This is the hard step. The first 2 are easy, right? Solve for Y. Okay. Now, for this situation, the only thing we're going to be careful, and as we do this, we can probably explore some good and bad math. There's no right answer of what to do. We just have to keep messing around until we get Y by itself. So, I will take any path to get there. What's up? What was your idea? She talked too much. What was your idea?
As in multiply the denominator, like the whole.
Multiply the denominator is I'm not saying this is right or wrong. Are you allowed to do that?
Yeah. And then it cancels out on that side.
You're allowed to do that?
Over 1.
You are not allowed to just do that.
On both sides, my bad.
You are definitely allowed to do this, right?
Yes.
There are only 2 things in math that you're allowed to do. That's one of them. Do the same thing to both sides, whether it's adding, subtracting, multiplying, dividing. What's the other thing you're always allowed to do?
Factor.
Fine, there's probably a lot of things. I just mean if factoring doesn't change anything. It just moves stuff around. I'm talking about that was a change. We multiplied, right? That changes stuff. There's only one other thing you're allowed to do that changes stuff, and it's multiply by 1. You're allowed to multiply. Like, that's that complex conjugate thing from a long time ago. Well, not even our class, but.
Multiply by something over itself.
Because it might help you get rid of a denominator. Now, this is going to help us get rid of a denominator, right? But we have to be super duper careful. Because what's our new equation now?
2x plus 5.
I'll go slow. I'll distribute in a second. I'm going to go really slow. Because on this step, I have to make a note. That blue thing did something. I'm going to call star, 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 and write note. And this may never matter. This note may never matter ever in its life. But I really have to write it. What did I just do that changed math? And I drew it blue for a reason, because the blue lines is what did it.
You cancel that.
But why would we have to make a note? That's a good thing.
Basically, we just try to get rid of a denominator.
And why would that matter?
Because we do not want to have to deal with fractions.
Right. So why did we want to get rid of the denominator in the first place? Yeah, but why get rid of the denominator? That's just a random idea.
We're transposing to find y. So.
Why is the denominator hard?
You get the coefficient greater than 1.
But why? You're saying what, not why.
It's just so hard to do with fractions.
Fractions are hard. That's actually probably a decent answer. Fractions, there's something bad with fractions that we have to make a note of. There's one bad thing with fractions. What's the bad thing with a fraction?
That was a bad number?
Yes, that's what my note is. What is the bad number that could have been there?
0.
What's 2 times 0 plus 5?
Oh, no, wait.
No.
common denominator,
no,
right?
Yes.
It's literally
Or
impossible
less-
to get 0. Oh wait,
Greater
5.
than
Wait,
zero.
-5 is inequality. Wait.
This is my note.
-5/2.
Indeed. Now, what I'm saying is this note may never matter, ever. But what do I know about that situation right there in this note?
Y cannot be 5.
Y should never, ever be that. Can it be other stuff? Can it be any other stuff, literally?
Yes.
But it can never be that. That is my note. That is what I'm making a note of. And why did I make a note of that in that blue spot? Because look at my new stuff that we just decided. We got rid of that option.
Yeah.
That's kind of crazy to get rid of that option. We had to make that note. Now, I promise you this is not going to matter. This is probably not going to matter because they're probably not going to have a Y value of that. But I still want to make a note just to be careful. Okay, let's keep going. Any other math ideas when you look at that? Like that? Okay. 2xy plus 5x equals y minus 3. This is where I notice people get like lost in the weeds and they start forgetting what our goal was. What was our goal? Get y by itself. That is the goal here. Divide by y.
Well, we
Hang
have
on.
to prove.
Oh, yeah, that too.
Divide by y? We just worked so hard to get rid of a fraction, and you're trying to get a fraction back in here?
Why would we
Add 3 to both sides?
No, add y.
Subtract 1.
Yeah,
You
subtract.
can't subtract.
You can. All of these are good answers. All of these are good answers. You're allowed to do any of these, and you'll get to the same spot. We're allowed to do any of these, and we'll get to the same spot. But let's.
Are we allowed to subtract y?
Y?
We can subtract it.
You can subtract y,
Of course.
but
Subtract y from both sides?
Yeah.
And then you would just have negative y, right?
Yeah.
You
we
would
are trying to solve for y.
From 2xy, right?
This is not.
Just double check.
No, this is good. This is great. Both work. I'm trying. I don't know which. I think it's the same number step. It's 2 steps either way. It's 2 steps either way. I'll go with the 3 because it's the first one. 2xy plus 5x plus 3 equals y. Next step.
There's nothing else. Is that the answer?
Minus 2xy.
Oh, shoot.
We don't have y by itself, right? It's 2 steps either way. Doesn't matter which one you move over. You would have had to do both things.
Yes.
So now we've got 5x plus 3 equals y minus 2xy. Crap, we don't have y by itself.
Back down 1.
Factor of y.
Factor out of y?
Yes.
Like that?
Yes.
Boom, boom.
With 1.
Minus 2x.
Could
Equals-
you have divided by negative 2x? Or no?
Yeah, but you're just making fractions here. And why are you trying to make fractions when we worked so hard to get rid of the fraction? We worked really hard to get rid of the
What
fraction.
if there was like no common variable?
We made there be one by moving them to the same side as their common variables. Look, there's actually one on the left and the right. Oh, no, there's not one on the left. I lied.
Okay.
We made there be one. That was the whole point of getting y by itself. Oh, no, if there was no common variable, that would mean we already had y by itself and you were done. The only...
Like, as in, like, if it was only like negative 2xy.
And yeah, then we would divide by negative 2x, and you're done. And you're done. But there is a y there, so we got to get it. All right, I think there's one last step. Divide by
It's negative 2x.
the whole thing.
1 minus.
So we've got y equals 5x plus 3 over 1 minus 2x. Or f invert x equals 5x plus 3 over 1 minus 2x. Cool?
Mr. Cole,
Yes.
can you explain again
I'll zoom out.
the note?
Oh, the note?
Main purpose?
Yes. The note was for domain purposes, or for the case where they said plug a number in, or they said set it equal to 0. If they were like, hey, set the inverse equal to 0, and we set it equal to 0 and solve, and you get that number, you're like, oh, wait, we couldn't have ever had that number in the first place. Chances are, though, no, not chances are. The fun fact is, we said right there that y can never be that number, right? which means in that thing that we've got going on, in that inverse, there is no number that will give us that y value. So later in the year, later in the year, we're going to talk about asymptotes, this thing called vertical asymptotes, which is never that number, and that's kind of what we found. But we wouldn't be able to find that vertical asymptote now in the problem. If we went to find our asymptote now, it looks like it's one half. Our x changed to 1/2. Look at the bad number on the bottom right there. It's now 1/2 instead of 5/3. So we wanted to make a note of it while we had it at the beginning of what the bad number or the domain restriction is for the regular function. It doesn't matter. That's why it's a note. It doesn't matter, but later in the year we'll get to things where it will matter, and it was important to make that note.
And regarding the
Mm-hmm.
numbers, isn't there a point where we switch back the x and y?
No.
We only switch.
You switch them once. Switch them once, solve for it. Basically, if you want to boil inverse down into the simplest words, switch x and y, solve for y. You've already got y by itself usually. Switch x and y, solve for y. That's the premise of an inverse. I have an idea real quick before. I know. Yes.
Why is it not just -2x?
I might have messed up. Did I make a
You just added a 1.
right here?
Yeah. Where'd the 1 come from?
Oh, the 1 came from. So when you do this step right here, which is factoring out, this is called factoring out, right? It's basically reverse distribution. Like right here, if we did the distributive property, what's y times 1?
Y.
There's your y. What's y times negative 2x?
So if you just do -2, it wouldn't be right because when you distribute.
Because you'd still have this. Well, oh, you're talking about right here?
Yeah.
We didn't touch this 2. These are 2 terms.
No, but
That's 1 term. That's the other term. The sign stayed the same.
But you have to have that 1 as a placeholder.
Absolutely. Oh, then it would be a 0. Pulling a y out of a 1
I
or
thought it was just -2x, not 1 minus.
what we essentially did, and it's really hard to see, or I mean, it just gets so messy if you really do try to write it a bunch. But the distributive property, here we go. Watch this. This is 2 times x plus 1. Side note. What does the distributive property tell you to do?
Distribute the long term.
Distribute what?
The 2.
The 2 what?
Two to each
The-
value.
Okay.
Distribute
That's what I was looking for, right? Because just saying give the 2 to the x doesn't help us, right? Multiply the 2 by the x as 2 times x, right? Well, not that one. This is 2 times 1, and this is 2 times x, right? Okay, so you actually would probably get something like 2x plus 2. Okay, now let's start with our 2x plus 2 and just see what this looks like if you reverse it. This is kind of what we were just doing, but with the y, right? We're going to take out the common factor. What's the only common factor? Looks like a 2. Technically, we're not just factoring out. That's a bad way to think of it. Technically, we're dividing by the common factor on each one. And then you put the common factor out here. What's 2 divided by 2? 1. What's 2x divided by 2?
x.
X. So x plus 1. But if you're scared because you don't know if you factored good, well, if you don't know if you factored well, just redistribute and check. If you don't know whether you factored well. So if you would have gone here and like you were saying, just written negative 2x because it's kind of tempting, just redistribute and see if it works. You'll be like, oh, that doesn't give me the same thing if I carry out that multiplication. Okay, before we move on, and go ahead and start looking for another problem. But I am going to post something that will, I'm going to grab like a bunch of, I want to find those double ones though, because those double ones are a little tougher, right? They're like double fractions where it has 4 terms. Inverse functions. Those are, what are those called? Rational? Rational terms? Be looking for another one while I do this. Man, they're too easy. Anybody got one?
Number 19.
Okay. Man, the world is not giving us complicated inverses like that.
That means the world doesn't like the movie.
Yeah, or nice. Or nice.
The world is still good.
Man, they really are. The world, like you said, the world is really nice. There's one. Found one of them. Yeah. It is very I just looked at like 4 different websites and it wasn't super. Here's one extra practice problem. I'm putting it next to it. If you're watching the video, you can just grab this and try to solve it. I'll go look for some more and put it here as well after class so we can keep working. That is interesting though.
Mr. Kovac,
Yo,
the denominator is usually is it the horizontal or the vertical
Are-
one? Yes,
are you talking about last notes? The denominator is going to be the vertical, but we'll spend a whole 2 weeks or 2 classes doing that. Yeah, the horizontal is different. The horizontal here would be 1/1, and the vertical would be -5.
it'd be y equals 0.
Mm-hmm. All right, let's move on. There's one practice. I'll try to find some more and post them if I can. Anybody got? Oh, you did say one. Which one? 19. A cannon. Ooh, that's a fun one. This is basically what we did for our lab, right? This is basically like the actual like lab, but turned into a cannonball instead of a tennis ball. And probably with a calculator. So I'll pull up a calculator on Google and we can use it and see how we would use a regular calculator for something like this. This would be on the calculator section if you had a question similar to this. All right. Cannonball is fired out to sea from the shore. Follows a parabolic path. What's a parabola? That's the key word there. Like that? Do you think it fires that way or the other way? Probably that way, right? You think it's a happy parabola?
Oh, sorry.
I've seen a cannonball before.
I confused it.
Maybe a watermelon underwater would go that way. Or
Sad one because
a pendulum. Keep going. Sorry, what were you saying, Joseph?
no, I was saying it's because the squared value is negative. So
You know why else it's because? Because it's a cannonball. That's why else it's.
being thrown by sea level, right?
technically.
Okay, sorry.
Really good drawing.
Thank you. I try.
Why would gravity be inverted?
What is the maximum height? That's probably the max height, right? So that's question A, right? What is the max height? And how far does it travel before it splashes? That red distance right here is probably question B, right? Okay. Interesting. Anybody have any ideas?
Well,
I don't want to do it for you.
for the horizontal, we basically define one of the rules, right?
Or both even.
Yeah,
And just subtracting them or seeing how far it is from each other. Okay, so that's a good thought. For part B, I'll do over here. Joseph said, we're basically finding the roots. Right? I agree.
but if you're talking about the maximum height, would that be the maximum, basically HK?
Ooh, with the max height, if A is technically the max height, wouldn't that be something like H comma K?
Yeah.
Which is called something. It has a name. Interesting. And wait, we did learn about completing the square to find a vertex, right?
B squared over 2A.
No, you've forgotten already. But you shouldn't forget. I said this, and you said, no, we won't forget. And I said, you're going to forget. And then you remember what I said when you do forget how to remember it? You've already have it memorized. You just forgot. How do you have it memorized?
The quadratic formula.
Okay. What's the quadratic formula?
Negative b plus or minus square root of b squared minus 4ac over 2a.
Okay, so you already had it memorized. You just forgot you had it memorized. Anybody remember how?
Is
If you took the square
is the
one.
discriminant? Wait, the b is that.
That's it.
We're finding h. I thought you mean completing
That's H.
the square.
This is H. That's H.
I thought you mean completing the square.
You had it memorized. You just forgot you had it memorized. We did that for a whole day. We found H. And then you did a lab and you found H. That's H right there. Okay? You have it memorized. You don't have to rememorize it. That's H. You do have to remember where to go look for it. Okay? Ooh, but they were super sneaky with how they wrote their function. Yeah. So they wrote h of x equals, what did they write?
10x minus 0.01.
Okay, we need to rearrange this thing so it looks like how we like it to look.
0.01x squared negative.
Negative 0.01 x squared
Plus 10x
plus
plus 0.
0. And which one of these is A, B, and C?
Well, A is a square, B is the 1 with the 1 and C.
Okay, so what does that make our vertex?
Negative
It's negative v over 2a.
Mm-hmm.
Negative 10
Negative 10 over
over
2.
2 times negative 0.01.
Wait, yeah, you were right. And here's, remember what I said this one would probably be? On the calculator section, right? Not definitely. You can 1,000,000% do that without a calculator. But, so that is possible to do without a calculator. But you might save a little bit of time if you had one, right? So that you can spend your...
It will be negative 0.01.
So, negative 10 divided by, parentheses, 2 times, what are we doing? Negative 0.01? 500?
But basically,
Basically? What do you mean basically?
it is.
It is 500?
Yeah.
Okay.
And then you plug that back in for function.
Would you put
Pause.
500?
What is 500?
500 is the y.
It's the K.
Rather the y, the highest point. So highest y value.
It's X.
Oh, the x. Yeah.
500 is the x value of
The vertex.
the vertex. And now what do we do with that?
Plug it in.
Which again, probably a calculator question, right? What-
Damn it, this paper doesn't have much space.
That's why I brought extra paper for you. Justin, do you need an extra piece of paper? H of 500. Somebody hit me up when you get it. I'm not doing it. I'll let y'all do it and then tell me you can use your iPhone for now, but freaking bring up.
Hold on, I had it on the- No, it's fine, top one.
What's H of 500? Oh, there's 500 squared. That sucks. Twin. Yep, you both got it? 2,500? So what is your vertex?
500, comma, 2,500.
But that is not the answer to the question, even though it's super helpful for the answer to the question. What is the answer to the question?
Maximum.
What is the maximum height?
It's 2,500.
Yes, this is y, right? Y max height is 2,500. I'll zoom out since we're zoomed in real big. Boom. Okay, that's part A. Part B is actually kind of easy now. Because we've already found something that really helps with it.
Well, the
So would it be
2005 with
maybe
500.
1,000? 1,000 zero? Because it's the vertex, so it's halfway through.
Mm-hmm.
So it's 1,000 zero.
Okay, that's one way to do it, right? So Ruth just said the vertex is halfway through, right? So it traveled half the way. So guess how far it traveled on the other side of it?
Another 500.
The other half the way, right? So because vertex is half, comma, 500 times 2 equals 1,000, and that's the distance traveled. Is that an okay way to do it? Heck yeah. Is there another way to do it that somebody actually already said earlier? It's not plug in 0. What is it? Find the zeros. So what's the function? H of x equals
negative 0.01 plus 10x.
like that. How do you find the zeros?
Well, basically would be
No, you should know how to find the zeros. Not know what they are, but you should know how to find a zero. No.
Like in
So you
500
equal to zero.
with X,
No.
0 to Y.
You set 0 equal to y. Because it's freaking called a zero. Because it's called a zero. Because that number is 0. And it's where it hits that, right? If that's your parabola. That's why it's called a zero. So how do you find it?
Set x to 0.
That would be the y-intercept. Right? Right? Because if x, look right here. If x is 0
That's y.
and y is 1,000, y-intercept, right? Set.
Set hx to 0.
Indeed. Set your y value, also known as your function value, equal to 0. And what do you do with the rest of this crap? Just a little bit of math, right? Looks like we need to factor out an x. Y'all cool with factoring out an x?
Yeah.
X outside of plus 10. And then what do we do with each of those? This is just what we've been doing recently.
X equals 0.
The first one is easy, right? X equals 0. That's a nice one.
And then we equate that one to 0.
Negative equals 0.
Carry over to 10.
Negative 10. X equals negative 10 divided by calculator for that, but you probably get,
Isn't that technically?
is that 1,000?
Oh,
So yes, it's
That's 1,000? But those are just roots. That's not how far the cannonball traveled. Think about the picture. What are the roots?
0, 0.
0 and 1,000? 0? So what does that mean about our cannonball?
It went 1,000.
It went 1,000, which is double the vertex. It's cool. It worked both ways. Okay, I'll zoom out. Leave it right there. I know it's kind of small, but that's just to get the whole problem in. Can you still see? Yeah. I'm going to save this.
Well, quick question.
Save. That means it's updated online. Heck yeah. Yes, sir.
Did we plug the 500 into the...
We never plugged it. Oh, no, we did.
To get the 2,500?
To get the max height, yes. When you solve for negative b over 2. So we talked about this, which is a little harder to memorize. But what is the actual? I don't like HK, even though it is true. HK is your vertex, right? I think there's a better way to remember vertex if you just want to do the hard memorization. If you just want to do the hard memorization, this is your real vertex. You know what the formula is? Or just, what's a better way to remember it? Because HK is not helpful at all, for being honest.
Negative b.
I think for me, I would the one A and have open parentheses x minus h and then plus.
Yeah, but it's hard to get your formula to that. You have to complete the square to do that. In order to not complete the square, what's the h? How do you find h?
Negative b over 3.
Okay. How do you find k? So how do we write what you just said?
F of
Hey, that's a better way to remember the vertex. I think. Because that tells you, I know how to find h, and then I plug it in. That is what that says. Find h, plug it in. The same thing. It is. You're right. Completing the square, if it gives it to you in completing the square form, first one's great. Because it's minus h plus k. Love it. But if they don't give it to you, which usually they don't, usually they give it to you in the R form. You know, the whatever it's called, standard. That's a little bit prettier.
Wait, what's completing the square?
Don't do it. We're never going to do it. We did do it for like 2 days. If you want to go back and look at the notes, you can. There were 2 examples. They were hard. We didn't like them. And then we said we're not going to do those anymore. It's when you do like you find the perfect square, you add it to the inside, but then you multiply it by the outside and also add it to the outside. Yes, it's like plus a blank. But then you don't just, and then you see like plus 9 inside of that. But then you have to go minus 18 on the outside because it's not just 9, it's 9 times the 2 on the outside. I don't know. We did it, and then we're like, but this is a better way to do it, I think. To find the exact same thing. Okay. More questions? We have plenty of time. We're staying all till we can just work straight through. If you need to take a restroom break or anything, just feel free to walk out, and we'll just work through whatever time we leave, 12. And if you want to stay after that, I'll keep working problems. I'll be here till 2. So.
It'll all be posted, right?
It already is. And the video. Video will be posted too. And the notes we just did. All the notes though, when you pull it up, don't be like all the notes are scroll down a bunch. They'll be down here. Cool. I'm just copying and pasting the ones we do in that order. Find one. Love it. 24. Oh, great. And it is here, even though I said it wasn't super important. They do have a question. They do. They have it, which means it's pulling on test 1. Is it going to be on the final? Probably not. Is it here poking its head on test 1? Good thing we're reviewing it. I'll go pull up a worksheet and post it. This one will be easier than the last one to find. Sure, 20's next. Don't let me forget. Okay. Why did I do that? Use Descartes' rule of signs to determine how many positive and how many negative row zeros. All right, just a quick review because we did it so quickly. Positive. What did we look at? Sign changes, right? Straight up. Positive was the easy one. Negative, what did we look at? Yeah, we had to plug in something. It was f of negative x. And then sign changes. Cool? No rush. I'll leave it. Okay, we can do them in those 2 steps. So what's the formula? I'm just going to copy this real quick so I have it up down here. I know that's like double copying. Boop. Boop. Where'd it go? Oh. Sorry. Wasting your time. Okay, how many sign changes do we have? We have.
We start counting before
You can just write positive, negative, positive. You don't count before the first term, but you include the first term in your counting. I'm not counting sign changes right now. Right now, I'm just writing the signs in blue. Negative. Oh, wow, that's a lot. I can tell already without even counting. Okay, so then I'm going to slash each time it changes. 1, 2, 3, 4. So 4 changes means how many positive real ones? Positive real roots are either 4 or 2 or 0. And that's it. We're not solving, yeah, that's it.
4, 2, or 0?
It's just you drop it by 2 every time. Even if it was 5, it'd be 5, 3, or 1. You just go chunk, 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 all the way down. But now, this is not on the test, but we know why you had to chunk it by 2. You know why you had to chunk it by 2?
Because it's to the 4th power?
Okay. No, because if it was a 5th, we would go 5, 3, 1. Why'd you chunk it down by 2? We haven't talked about this yet. We'll probably do this after the test. But it's a fun thought. Why is it chunking down by 2? It has to do with one of the words on there, and there's only like 5 words. One of the words I wrote. It has to do with one of those 4 words.
Roots?
Mm-mm.
Real.
What's the opposite of real?
Imaginary.
Imaginary. What does imaginary have to have?
I.
And when we did imaginaries the other day, we did them on the chalkboard because I forgot the computer. They always had They always had 2 things, right?
A positive and a...
They always had a plus or minus because of the freaking quadratic formula. There's the 2 that it's chunking down. Because that's how many positive real roots you have. If you have 4 real roots, you're done. Those are your roots. Because look, you can only have 4. If you have 2 real roots, you know what that means you have?
You have 2 imaginary.
2 imaginary. You're not allowed to just have 1 imaginary. That'd be impossible. That'd be crazy. Because then you'd be like, what happened to the quadratic formula?
It's 2 real, 2 imaginary? If it's 4 real, then 4 imaginary?
No imaginary. If it's 4 real, look at the highest number up there.
It's still 4.
So those are the real. Those are all the roots.
But if it's 2, then you get a positive and a negative.
Yeah. Well, 2. If there's 2 real roots, which is like, I don't know, say it's 1 and 5. Those are your real roots. You also have 2 imaginaries. I don't care what they are. They're plus or minus square root of -4. Who knows what they are?
Okay, why can't it be 3?
3 what? Imaginaries?
Yeah,
Or-
real.
Because if it were 3 reals, how many total roots can you have in this problem?
4.
Okay, so if there's 3 real good ones, Real means good,
Oh,
basically.
an imaginary is.
Has to have both of them, right? So if there were 3 good ones, then you'd be like, oh, well, the imaginary is like negative 2i. And we're like, hold up. What about the positive 2i? It's got to hang out there as well. Because when you square a positive 2i, it's going to turn into regular negative, like a regular number. That doesn't matter so much. This is what matters, but I just think it's a fun talk. Okay, and then we plug in for the blue section, which is the, oh, I messed up. I totally messed up. That's supposed to be all blue, right? But I don't think I'm allowed to select it. Oh, I am. Sorry. Oh, man. I'm just going to leave it. You understand, hopefully. Oh, maybe this will work. Nope. Okay, never mind. It's just the wrong color. I'm so sorry. All right. P of negative x. First sign change or not?
Yeah.
No, it doesn't.
Because it's even. 2x4. Second thing flip-flop. Positive 7x cubed. Third thing flip-flop. Nope, because it's squared. Fourth thing flip-flop. Yep. Last thing flip-flop. Nope, because there's nothing to plug in. So that negative x, technically, if we want to make a little note, only flipped positive to negative or negative to positive for odd exponents, right?
Wait, are we doing B, right?
Yes, we're doing the negative section. Like, how many negative real roots are
It's
there?
only if it has an x, like plus 3.
Plus 3 doesn't flip because of when we go to plug in negative x, there's nowhere to plug it into. Okay, so our new function is 2x4 plus 7x cubed plus... what's going on here? There, yeah, plus. How many sign changes were there? So if we're just going to follow the same kind of pattern, what does that probably mean?
Would that mean that all or
No,
No real?
imaginary?
real.
Solutions?
Look at the last thing.
Roots?
Last one are positive real roots. This was for, because we plugged the negative sign in.
Not imaginary.
No, we plugged in a negative sign. We didn't plug in an I,
Oh,
right? Look at that negative sign. We plugged in a negative sign, so it's no real
oh.
negative roots
No real negative.
because there's no sign changes. The first one had 4 sign changes, so there are 4, or 2, or 0. So you know what that actually told us right there? Even though it was longer to do than probably just doing the synthetic, that told us when we go and do synthetic, we don't have to check any of those negative numbers. We can just cross out the negatives right away because of that rule. Okay. Now it says, show that 4 is an upper bound. And when you see that word bound, oh, that didn't work. Wait, yes it did. When you see that word bound, just think synthetic division, see what happens. Cool? So, draw this line. Boop. Here's part B. 4 is an upper bound. Let's just do our synthetic division. 4 backwards L. Any missing numbers?
No.
2, negative 7, 1, negative 18, 3. Stop me if I screw up. 4, 3, 2, 1, 0. Yep, no missing numbers. 8, 1, 4, 5, 9.
No, that'll be 20.
Thank you. 22, 8, 11. Gasp.
Yes.
It doesn't work, but look at what all those numbers are. No, they're not all odd. They are all positive. Most of them are odd. They're all positive, which means no real. No, that's not what that means. That's freaking the last test. I was just going with what you said.
I was just
What's the problem to ask for?
lower bound for real zeros?
No, lower bound.
Yo, read. Thank you.
What does that mean?
We plugged in 4. I don't know. Just read. Just guessing. Don't guess. Don't guess answers. Never guess an answer. Read and think.
Sometimes guessing.
No. Do not guess this when you're looking at it. We plugged in 4 for synthetic. We go back to the problem. What did they say about 4?
Sure that's the upper bound.
Okay, so that means 4 is upper bound. So what do you think that means has to be the condition for an upper bound, just based on context clues? If you never learned it in your life.
Would it be like the value that does not get, like if we add an x value that?
No, I'm just saying, like, look at the problem we just did.
It's an upper bound because they're all positive.
There you go. Upper bound is all. It's actually the word non-zero, even though it sucks. All non-zero. Wait, free. Non-negative. Sorry. All non-negative synthetic division answer. Just a random rule. But you know what that says? Don't try 5, don't try 6, don't try 7, don't try 8. You're done. You don't have to try anything higher than 4 if you have that big long list of synthetic triers.
No.
Negative 1's exactly the same, except you're going to see a different condition happen. So let's check it out. No, negative 1. No, actually. It's a little bit.
Give us a number and we try it?
Yes.
That's it?
Yes.
Why?
Well, the trick would be as you're working the other problems, the synthetic type problems, you know how you make the TCLC list and then you try all the numbers? It's not that you are looking for this, but if you see that happen, your brain can go, oh, cool. Now I don't have to try 8 or 12 or... Your brain can see that happen on that 4 right there and say, oh, now I don't have to try any of the bigger ones. Positive means no more bigger ones. Or try them all. Because you don't like the shortcuts, just try them all. But this is just a shortcut for synthetic saying,
But it didn't equal to 0.
right, no. 4 is not a solution.
Okay.
But because they were all positive, now we don't have to try 5, 6, 7, 8, 9, 10.
We were trying to see.
No.
Why were we trying for?
Well, just because it told us to.
Oh.
No reason.
Okay.
I'm just saying, if you're saying, why would we do this? Saying, well, you wouldn't be looking for this. You would be doing your normal problem, synthetic division. There's like 20 of them. You happen to do one of them that's not a solution. But you see that. You see a bunch of positives in a row. Now your brain's like, oh, cool, don't keep going up. Go to the negative side or something. Like, I don't know, we can do a synthetic next and we can probably see it happen at least once. Negative 1, 2, negative 7, 1, negative 18, 3. Drop it down, 2, shoom. Negative 2, negative 9, 9, 10. Stop me if I mess up. Negative 28. Positive 28. 31. Oh, shoot. That is not all negatives, is it? What happened there? Positive, negative, positive, negative, positive? Flip, flop, flip, flop. If it does that, you know what it means? That's what it means. If alternating, dot, 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 lower bound. And here's again the thing you said, why did we try negative 1? It's not a solution. That's true. That 31 means not a solution. I don't care that it's a solution. You know what numbers I now don't have to try in my synthetic?
Negative 1.
Or,
Positive 1.
no, you still have to try positive 1.
Anything below.
Anything below that now.
Negative 2.
Right, or negative 3, or negative 4, or negative 5, or negative 6. If you remember how we make the TCLC thing? And you know how there's like a billion numbers in the middle? This is just a shortcut for you to see, oh, look, they alternated. I don't need to keep going down. Or, oh, look, they're all positive. I don't need to keep going up. It just helps you do less synthetics. But do all the synthetics if you don't like these shortcuts. Please do all the synthetics. Usually there won't be that many. Like, what's the problem? What's the division problem here? Right there? Look at that. That's a 3 and a 2. That's 6 total. Technically 12 if you do the negatives. That's 12 total synthetics. There's another synthetic right there. Okay. Let's keep going. That way we don't run out of time.
Wait, did we make any notations for the
Lower bound?
yeah.
Yeah. What did we say? We said if alternating, then it's a lower bound, and it was alternating. Positive, negative, positive, negative, positive, negative.
So the boundary is a lower than negative.
No, the boundary is -1.
So what happens if I honor?
That's not a condition. We don't know. There's no special rule for that yet. The reason that it's alternating and not all negative is because if you multiply two negatives, you end up back at positive. Negative, positive, negative, positive, negative, positive. It's not like positive where if you just keep adding numbers, you go up. Or not adding, but multiplying. Technically, it's multiplying. If you keep multiplying positive numbers, you're always going up. Hence the positive. It's an upper bound. It's never going to get negative again. If you keep multiplying negative numbers, you're actually going to go like this. What's going to happen is you're still going to get bigger in number. Like 31. See how it gets bigger every time? But you're going to go like, this is a weird way to think about it, but it's an oscillating growing function where it goes like this. Right? Because you're getting the number bigger every time. You're just going positive, negative, positive, negative, positive, negative each time. Oh, that's kind of saying lower bound. That whole like, see how it goes 2, 9, 10, 28, 31. It's going to keep getting bigger every time. Just flip-flopping signs, lower bound.
So -1 is lower bound?
Yes.
And -4 is
Yes.
positive?
And the proof is in what we did, the red and blue underline there. The proof is in alternating signs or there.
So alternating signs show negative.
Yes. And upper bound is all positive. And that's the reason it's alternating and not. Good question is, why isn't just all negative means negative and all positive means positive? It's because multiplying two negatives gives you a positive back. So here's like a negative number. And you multiply by a negative. Oh, you're positive. Multiply by a negative. Oh, now you're negative. Multiply by a positive. Multiply by a negative. Multiply by a positive. Multiply by a negative. Absolute value is increasing while the sign is alternating. Okay, what else? We still got 40 minutes. We're at plenty of time. Oh, you said that. Oh, sweet. What a great question. And there's so many ways we can do this now. Because of all the stuff we've learned after we learned this, you're not confined to the one way we learned when we did this at the first time. Boop. Boop. Graph the polynomial. I'm going to go grab a graph. I know y'all don't have one, but just so we can be careful, because if you're taking a test, I'll provide you with the graph, and the function will fit on that graph. Like, it'll be nice and neat. It's not going to be just blank like this. What?
Should there be an x squared?
Oh, shoot. I believe so. Well, you can do both. You can still graph that line, right? But you're right. I think there's definitely supposed to be an x squared there. Let me catch that in a second, and then I'll fix it. I'm just looking for, what's the y-intercept here?
27.
I think it's going to be like 27 minus 4. You'll see why in a second. I need a blank one so I can make the labels myself. Is that good? Dang, sorry, I'm sorry. Taking too much time. But freaking give me a good graph. Why is it so hard to find a graph? XY graph 3. PDF. Haha. Haha. Oh, that only goes to 12. There it is. Close that. Boop. Create it. Sorry. No. Why is life so hard sometimes? I guess we could just. Remember the grades, full page. 4 quadrants, full page. There.
Why not just take a screenshot of that blank one?
That's what I'm about to do. But I'm going to do it here. Or no, I'm not. Boop. Whoa. Didn't like that. Sorry. Boop. There we go. Okay. So what's this actually asking us to do if we were going to square it ourselves? if we weren't trusting me typing and we were going to square this thing, what's it asking us to do? Where's the square probably supposed to be?
In the brackets.
Ooh, outside the brackets, right? There's probably definitely supposed to be a square right there, wouldn't you say? But could you graph the line as well?
Yes.
You could definitely graph the line. Distribute the negative, combine like terms, see what happens. It'd probably be the thing that I messed up. And if I mess it up on a test, by golly, you just solve the actual problem. Don't expect me to, I'll grade both or what, you know. But what I messed up is if I wrote this originally and you were taking a test, just freaking distribute the negative, combine like terms, and graph that line, and your life is easy, right?
I was looking at this from, remember it talked with transformation?
Oh, you're right.
The negative on the outside, I was like, oh, that's like
A vertical reflection.
yeah.
Well, that makes sense because look, negative x right there. That's a negative slope, right? And the plus 2, here, this is fun. Holy crap, you're right. So this is the normal line, right? Technically, and then we'll go back and do the squared function. But this is just for fun for the line. Here's the normal line. We're going from 1, 1, and we're going all the way to, that goes to 14, so we need to go to 14. Is that cool? And we're going down to 14 too. There we go. That's the normal line, right? So what are the two reflections you or transformations you saw?
You saw a vertical reflection.
Okay, so that's like taking that line and reflecting it vertically, right? So like this. Whoops, not like that. Like this. That's what you're talking about?
Yeah.
Okay, then what else did you see?
We saw horizontal shift by 2.
Horizontal shift by 2. Chunk, chunk, like that? Okay, what else did you see? Up 27?
We saw vertical, yeah.
So it'd be like way up there?
Yeah.
Okay. Does that look kind of like negative x plus 25? Yeah, probably. Probably. But that's not the problem that we're actually going to do right now. We are going to say, that's the typo. Here's the real problem, is graphing this function. Okay? Man, I didn't even get a big enough graph paper. I'm going to have to add some numbers up at top. What do we know about this function?
Wait, what?
What do we know about that function?
We know that it's sad.
We know that it's a sad parabola, right? Okay, what else do we know?
One of its zeros is negative 2.
One of its zeros is negative 2. So P of negative 2 is negative 2 plus 2 squared plus 27. Watch what happens here. That's really kind of tricky. Negative 0 squared plus 27 is what?
27.
No.
27.
So that's not a 0 then, right?
1 is
What? That's the point 2 comma 27. Right?
Wait, did you get the negative 2? Wait, is that just a number you put?
Yeah, well, we were just trying negative 2 because it really does look like that should be a 0 based on what we've done in class. We see those parentheses and call it a 0 all the time. But just because we think it, I checked it, and I'm like, oh, crap, it's not a 0. But that is something that helps me graph this function. You know what I'm going to go do now? Plot that point way up here. Oops, that's not that point. That's that point, right? I don't know exactly where 27 is, but let's just call it there. 227. Negative 227. Okay, so that wasn't a 0. So we still haven't found our zeros, but that's okay. Let's keep trying. How can you find zeros? Equate it to 0 is the way we try that, right? So 0 equals negative. What was the thing? X plus 2 squared plus 27. Math rules tell us to do what?
We basically distribute the...
No. Do the easy stuff first.
Why
Thank you.
Yeah.
You're right. You could do FOIL. You could combine like terms. But by golly, if you get an easy problem, do the easy stuff first. What's the next easy thing to do? Sure. Divide by -1. Oh man, this is making this problem nice for us. 27 equals that crap. Oh my goodness, I see something even crazier about to happen. Oh wait, no, that's actually bad. I thought it was going to be nice.
Root.
Yeah, that's the next thing, right? Root? Oh, crap. What did we do?
Root of 27.
It's not the root of 27, it's
Plus or minus
root 27 equals.
equals x plus 2.
We're almost done. X equals.
Plus 2.
No, be careful.
X equals plus or minus 27 minus 2.
Plus or minus root 27 minus 2. So this is actually turning into a calculator portion of the test, which is totally okay. That's half the test. What are those numbers? We got to find those numbers. Grab a calculator. Grab your iPhone. Grab your calculator. We got to find those numbers. In order to graph it, we got to definitely find those numbers. Root 27 minus 2. Negative root 27 minus 2.
This is why I hate the calculator.
Square root of 27 minus 2. Anybody get 3.1, 3.19? 3.2 if we round up by to the third?
Oh, jeez.
I'm just going to go well, we're just graphing, right? Graphing is okay to not 3.19. Okay, what about the other one?
7.16.
That's just throwing a negative on the front of it? Negative. Negative 7.196?
Negative cell phone, yeah.
Okay, those are the two x-intercepts, right? Those are those two x-intercepts. So we've got 3.19, which is like right there, right? And then what's the other one? Negative 7 point. I'm just going to say negative 7.2 while I graph it. Because you don't know where 0.19 is and 0.2 is on that graph. Oh, look at that. Holy crap. I've got three things that I think kind of help. Is there one more thing they wanted us to know before we could just draw the thing?
Y-intercept?
Yep. So how do you find a y-intercept?
Basically plug 0 or look.
Basically just plug it in, right?
Yeah.
So f of 0 equals negative 0 plus 2 squared plus 27. Negative 2 squared plus 27. Negative 4 plus 27. 23. Oh, dang it. I was really hoping that was going to be on the graph. Wait, what is going on here? No, that's fair. Oh, interesting. Negative 2, you said was a freaking, what's it called? X-intercept, but it's actually a special point, and I didn't even realize it. It is. Look at h comma k.
Oh, yeah.
Yeah, in the form of. So even though it wasn't perfect, that is, and it doesn't say label it, but it's worth noting, this is actually the vertex. So it's pretty cool that we found that. That's the vertex. That other thing is just a random point. Oh, no, it's not a random point. This is the y-intercept, yeah, of 23, or 0, 23. And now we're pretty clean to draw our graph. Whoa, too far away. This is a very skinny, sad parabola. I can just do a thicker line. What am I doing? I'm going to make it green. Very skinny, sad parabola.
We could also just do transformation.
Yes, but it did say clearly label the x and y intercept. So that's why we solved for it. Because without the transformation, it would have been really hard to know exactly where it hit those x and y intercept perfectly. But yeah, you could absolutely do transformations. It flips, it shifts to the left, and it shifts up.
Question.
Yo.
So, first, just to go over like what you did, you used the -2 because it seemed like a potential 0, which gave you -2, 27, which is the vertex. So under that, what you were doing, all of that math was to solve for x-intercept.
That was the green. Green was the vertex. Good call.
Right. And then under that.
And then I'm gonna
That was to solve for the x-intercept.
This was to solve for zeros. Hence the literal. These are zeros, which is the reason we knew it was zeros is literally just this. Let me do it in highlighter.
Yeah.
This right there. That's the whole point of a 0. And then what were you gonna say for the last one?
To solve for the y-intercept.
And how did we know that?
You did f of 0.
Boom. Because x is 0, not y.
Right.
That's the easiest mess up I've seen people make is they just switch which one you plug in for what.
Yeah.
But if you do mess up which one you plug in for what, just go to the graph it, and you'll see what it is, x or y. If you mess it up, that's okay. Just go to the graph and you're like, oh wait, I thought I was doing the x system, but when I when I put it on the graph, it actually turned into the y one. Because when I plug 0 in for x, you have to get the y-intercept because it's 0, whatever.
And then for the zeros, you got
Ugly numbers, but this type would be on the calculator.
Where it came from.
Yeah. If you were doing this on the non-calculator, it could have been very similar. Just instead of 27, this might have said 25.
Okay.
And then your life would have been great.
Yeah.
Because it would have just been 5 and -5. And that's cool. Because 5 plus 2 is 7. And 5 minus 2 is 3. And you're home. That would be on the non-calculator part. On the calculator, it would be something like this, which is ugly, but still doable. I don't know which one. I don't know exactly which one's going where, I would tell you. But I do know the types.
All your office hours for Monday, Wednesday, and Friday is after class?
And before.
Before? Okay, so
Immediately before.
Friday morning?
Yeah, at 8. At 8.
To your office?
Mm-hmm.
What time do you before you do you leave campus at 4?
Today?
No, but each day.
It's different every day. I leave.
I have the place to do so. That's what I'm trying to find out. Because the way things is for me, it's I don't get all the classes till after 3:50.
Oh, yeah. Usually I'm off by 4 or 4:30. Yeah. But if you have a specific day, just text me or not text me, email me, and I'll stay on a day. I'm just not gonna stay. What if something comes up and then you leave and I'm like, okay, well, sat here for nothing. But yeah, if you have a specific day when you're like, oh no, I really need something, just email me and be like, hey, this Tuesday or this Wednesday. And I'm happy to stay. I'm not going to do it every day because my classes don't end. Then I just be sitting for 5 hours. Okay, more questions. We have enough time to do like 2 or 3 more. Let's see. Nope. Yeah, I can do 22.
This is updated for this year?
What'd you say?
On your website, on the pre-cal website?
What are you talking about? Yeah.
It's updated for right now, as what we're doing in class.
It should be. Look, right here. Hang on, save. If you go to the website right now and you click on the middle thing, pre-cal notes, it should be. I'm going to double check and make sure. Test 1 review, the completed middle one. Okay. It should have everything we've already done today, I think. Yeah.
All right, thank you.
Cool. And the video will be up. I'm recording right now. This video will be up immediately after class, depending on how long it takes to upload to YouTube. Okay. Use long division to find the quotient and remainder. Ooh, that's important that what they said. They said find both. So sometimes I just solve the problem and don't even read it. And I'm like, here's long division. And I'm like, oh, wait, what did they actually ask for? So they're probably going to have a remainder. That sucks. But that's okay. So we put the thing on the outside, right? 2x minus 1 on the outside. Big old division sign. Are we missing any terms?
X squared, x minus 1 is
What?
It's 2x squared minus
Oh, sorry, you're right. Are we missing any terms on the inside? No, I don't think so.
You missed an x.
Okay. I was going to get there. So do you have to write the x?
0, 0.
Plus 0x plus 7. You have to write that x. You can write minus 0x. It's the same thing. But you have to write the 0x. And if you're wondering, like, what the heck? Right there. There's technically supposed to be a plus x, technically, right? There's not one, so we got to throw a 0 in front of it. That's where it goes. Shoot. I'm not going to draw that arrow because we're going to have to write right there. Okay. Here we go. You'll hear yourself say 2x squared goes into 2x fifth how many times, right? That's what we always say. I don't like that. I like saying what times this equals this. Better math. What times 2x squared? What times 2x squared equals 2x to the fifth? Okay, you think 2x to the third? Ah. Just x to the third. You want to throw that 2 in there because, like, there's 2's, right? But then as soon as you do the first one, you're like, oh, that turns it into 4.
Yeah.
Bad. It's okay to make the mistake. You just go fix it after you do. Okay, so you're saying just x to the cubed?
Yes.
So that leaves us where I don't have any room to freaking write this. Hang on. You're saying 2x squared, what is it, minus 1 or plus 1? Times x cubed equals 2x to the fifth minus x cubed? Oh, this is weird one. Over? We haven't really done anything. We were just testing a thing to see if it works. So where do we write that at?
We basically put it below. So
2x to the fifth. Hold up. This is a weird one. Because look at where that x to the third goes. It needs to go with x to the third, right? Oh, that's weird.
it is creepy.
And then what do we do with all those things? We do distribute a -1, or you can call it subtracting. I don't care. There's a negative sign right there, right? Goes right there. Scratch it out. Scratch this out, and it goes right there.
It will become 0, 0.
So the first one becomes 0, right? Oh, shoot.
Yeah, it becomes 0.
The other one becomes 0, but you know what didn't become 0? That comes down with it, right? Ooh, I've forgotten to do one very important thing. We're doing good right now. We didn't do anything wrong. I've just completely forgotten something important.
Oh.
I didn't even write it, right?
Yeah, I did.
You said x cubed, right? It was x cubed? Cool. All right, now what times 2x squared equals 4x to the fourth?
X squared.
I like 2x squared.
Oh,
Positive or negative 2x squared? Probably positive 2x squared. So positive 2x squared probably gets us something like 4x4 minus 2x squared. Right?
Yep.
Draw a big old line. What do we do with all those terms? Subtract them, which means you go minus, plus. I think I was talking to someone in office hours earlier about, I'm just particularly like, I really like doing that scratch out thing when I change a sign. Because then you get to see if you've done it or not. Because a lot of times, I don't know, someone was in office hours, right? Or maybe that was a different class. Oh, we were talking about it? Yeah, because we were working a problem and it's just like, crap, I can't remember if I changed it or not. Because if you make one little mistake, then you have to go back and look. And it's like, crap, did I change that or already or not? I don't know. So I really like doing it this way so I can see, look, I've changed all 4. I've 100% changed all 4. I can see that happening. Instead of just kind of assuming I know what's going on and just writing the answer underneath, which I find scary sometimes. So 4x4 minus 4x4 cancels out. Negative x squared plus 2x squared is freaking x squared. Drop some stuff down. Plus 0x plus 7. Oh, it was this exact problem. We're about to end where we ended. What times 2x squared gives you x squared? 1. X? Go ahead, try them.
Half x squared.
Half x squared?
X squared divided by 2.
No, it's not. What times 2x squared gives you x squared? There is something.
0.5.
Yeah, it's just 1/2. Plus 1/2?
Oh, that's true. Just 1/2.
What's 1/2 times 2x squared?
1/2 times 2x squared is
X
1
squared?
with x squared, yeah.
It's just x squared positive. What's 1/2 times negative 1?
Negative 1
Negative 1/2.
Cool. What do we have to do with both those things? Subtract them, right? Which technically changes it to a plus, and now we're left with 7.5, also known as 15 over 2. If I'm being a better mathematician.
What about the
What about the x?
yeah?
What about what?
The
The
X.
x.
The 0x? Oh yeah, what about the 0x? Good question.
Carry it down.
It was
What
never
about it?
there. It was never there.
What is it?
The remainder.
You're right. We should carry it down. You're right. We should carry it down. What about it, though, is the good question. What's 0 times x?
0.
Sure. So, yeah, add it. Okay, we're done. We added it.
Okay.
Oh.
LMAO.
You get, no, bring it down for sure. No, for sure, bring it down. You're right. If that was a 1, we would be super careful.
So since it's
The reason I was not careful with it is because it was a 0, and my brain was just like, oh, it's done. It
So
took,
from the beginning, had to put 0 or no? I have to put a 0.
you have to. Because what if we got lucky that our work,
was clear.
well, yes, but didn't ever give us an extra x term? Our work could have given us an x term. As we were multiplying crap, look, our multiplication gave us an x to the third at one point, and our multiplication gave us an x squared at one point, right? It could have given us, like, say, a negative 2x, and then we would have had to combine 0 and negative 2x and had a number to work with. We just got lucky that at no point did our work give us a x.
Wait, which question is this?
Yes. I'm going to finish real quick, though, or I'll just do it on the right here. So what's the quotient, then? The quotient is technically your answer.
X cubed
X cubed plus 2x squared plus a half.
And what is your remainder?
15 over 2 divided by 2x.
Wait, be careful. Your remainder. Oh,
Ooh.
hang on.
A fraction of
Oh,
a
we
fraction.
basically be multiplying by reciprocal.
No. I've forgotten. I'll be honest. I've forgotten. I need someone to look at the notes. I know when you're writing your quotient, you put your remainder over the divisor because you have to, because it's part of the whole problem. But is the remainder as a name just that fraction? Go look at the notes and see. Or is the remainder including being divided? You know what I'm saying?
I think we just wrote the remainder by itself, but when we wrote the answer.
You have to put it as a fraction. That's what I would assume too. But I want to be careful and make sure we do it the way. I'm not lying to you. I know that's the answer, is to put it over the thing. But because this question only says find the quotient and the remainder and not find the answer technically, I think it's worth. Anybody know what section? What section do you think that would be?
This is 3.3.
Thank you.
Dividing.
So where do they call it a remainder? Oh, yeah. It's not divided.
Okay.
They divide it over the divisor and call it that. R by itself is just the R.
So wait,
Cool.
which one? What do we know when is which is which? Like, would we be using the quotient for the remainder over division over the divisor?
That would be if you're just giving the answer.
Oh, the answer.
Like, the answer is this plus this over the divisor.
Oh,
That's the full quotient. But they didn't ask you for, I don't know. It's weird.
but here it says find the quotient and
Right, that's why I did it as two chunks. If we were going to mash those chunks together to find the answer, if we were going to mash those chunks together to find the, I don't know if you want to call it the true quotient, like the true Q of X, or if you want to call it the technically answer or solution that the question always asks for, the usual thing is what you're talking about, which would be x cubed plus 2x squared plus 1/2 plus what? 15 over 2 over 2x squared minus 1. But that's not what they asked for, which is why I was being careful.
okay.
But honestly, if you're taking a test and you answer that way, you're probably getting full credit because I can see the remainder happening and I can see the Q, even though you didn't. So I'm not thinking that's like a killer.
I wish I didn't miss it. I feel like I'm reversing my brain.
That's not true. You're doing fine. Bless you, bless you. Okay. Got one more? We got plenty of time. Maybe two more even. Number one should be pretty easy, hopefully.
Oh, how do you find multiple?
Vertical line test.
And then one-to-one is
Horizontal.
boom.
1-to-1 is a function.
So, no, just the horizontal line
So
test.
if it's not a
Oh,
function,
if-
it is 1-to-1.
No, that's not true.
If it's a function.
It's just two different tests. Do both tests. It's two different tests. Do both tests. Vertical line test,
And
horizontal line test. Two different tests. Do both tests. Don't try to
Horizontal one was like.
just draw a horizontal line. Slide it down.
No, I was like asking what was it the test again?
It's what you guess. You tell me. Read the instructions and you tell me.
If they're 1-to-1. Oh,
That's it.
Oh, that's it.
Can you
This
do
is the
it?
test.
No.
Please.
Sure. Gosh, that's a lot of problems. This is so dope. Okay, here we go. Functions. What's the test for functions?
Vertical.
Vertical line.
Do this in blue. Vertical line test, right? Draw a freaking vertical line. That's a terrible vertical line. Also bad. There we go. Still not great. It doesn't matter. Okay, gotta hurry up. Does this pass the vertical line test?
Yes.
So what does that mean it is?
A function.
Function.
Okay. Check function. Does this one pass the vertical line test?
Which one?
The next one.
Yes.
It did a bit, but wait, yeah, it does.
It does, right? Yeah. What about the next one?
No. Oh wait. No.
What about the next one? Okay, so we've got yes, yes, no, no. Cool. Check, check, X, X. Get rid of that line, and we got to do it again for the horizontal, right? All right, here we go. Horizontal line test. We'll do this one in freaking orange, I guess. Orange line. Which one passes, which one don't? Does that pass the horizontal line test?
Yes.
Means it is what?
1-to-1.
Perfect. Does this pass the horizontal line test?
Orbit.
Wait, where?
Look right there.
No.
It hits it like 3 times. Actually, it hits it. Yeah, no, exactly 3 times, right? So no. What about this one? What about this one?
Yes.
Yes.
Dope. So we got X, X, check. Oh, my bad. Thank you. I wrote those with lines, not the marker. It's kind of funny. I think it's funny. The sense of humor is not a good sense of humor, I suppose. It's making me laugh. I wasn't even trying to write them with lines, but I saw they were lines. I'm like, fine, I'll just write the rest of them with lines. Okay, one more problem. Oh, 2 more. It's 10:41. We still have 10 minutes. Is this graph situation easy? Or
Where is that? Oh, it's first year.
like 16?
Wait.
Yo, what's up?
13.
13?
That's another inverse. I mean, inverses are.
That's an easier inverse than the first one.
But how do you prove that?
You just find the inverse, and it should be that.
Oh, just
You just find you could do it for both of them, and
I
really.
think the inverse property thingy is.
Oh yeah, that just is what the rules are. Actually, technically, what inverse property is do f of g of x and see what happens. Somebody besides them. Anybody else got problems? Some of these are actually, if we're looking at these, this is not that bad.
I'm not gonna lie, 13, I still don't understand.
13.
I think I'm just bad at fractions. The fact that it's a fraction, I don't understand.
Okay, let's do it. We can do 13 in literally 4 different ways to prove. There are so many ways to do this. I mean, there's technically only one way to do the inverse function property. But if the goal is just to literally prove that it's an inverse, then there's so many ways to do it. The first one is not a technical proof, but it is super helpful for you to know. You know the easiest way to check for an inverse is? It's the easiest way to do anything. What's the easiest way to do any math problem? plug something in. Pick a number.
Alright.
Freaking pick any number.
2.
F of 2. What's F of 2?
F of 2 is 1 divided by 0.
Oh, crap. You picked the only bad number. I lied. Okay, try a different number. 3. It gives you 1 over 1. So what point is that?
1, 0.
No, oh my
Oh
goodness.
no, 1, 3, 1, 3.
Yo,
3, 1.
this is
3, 1. Yeah, darn it.
no, this is so important to look at this and know what that is. Holy crap, we have to start over all year.
3 over 1 over 1.
It's still a B, right?
No.
It's 3 1.
What does a function do? Stop, slow down. What is instead of the, but use the, so yes, a function's an input for an output. What is the input?
X.
X, and what's the output?
Y.
Okay, put a pin in that. What was our input here?
3.
What was our output?
1.
Okay, so now what is a point? Put a pin in that.
3, 1.
No, what's a point?
Point is
A dot on a graph.
X and a Y.
An X and a Y.
Yeah.
An input and output is also an X and a Y. Plug in, plug out is also an X and a Y. So what point is that function representing at that blue, individual blue thing? Thank you. That's so important. This is like the only thing we've done, really, right?
Yeah.
We've done a bunch of extra stuff to manipulate that, but that's the crux of what this class is you plug a number in, you get a point. Okay, so now what would we do for an inverse to be like, oh, cool, we could just check something. What would you check? What's the definition of inverse?
Y. Negative X.
That's a negative number. What do you do for inverses?
If you inverse, you just equal Y, change you
1, 3.
Yeah, you flip X and Y, right? And inverse literally means you take X and Y, and what do you do with them? Swap them. So what's G of 1?
1, 3.
Well, let's find out. 1 over 1 plus 2 is... And what point is that? Okay. That's not a proof. That's just like seeing, oh, I think these are inverses.
Oh, just a G.
Yeah, it's just like, okay, that's not a proof. But that's pretty darn good. Like, oh, I'm pretty sure these are inverses. Now, there's a couple different... There's now like 3 still or 4 things we could do to really check. What's another way we could check? Anybody have an idea? Actually find the inverse of either or both? So f of x equals 1 over x minus 2. Step 1 is y, right? Step 2 is what? Wait, same step we did last time.
Solve for X.
Multiply by x minus 2, right? Multiply by x minus 2. Now what do we got? Y x minus 2 y equals 1. Make our little note if we want to. Is that what you're going to say? Oh, we can do that in a second. Yes, you're right. We'll do that. We will at some point. The notes said do it third. My college algebra notes said do it second. At some point, you have to switch x and y. I don't.
All part of one process, correct?
Well, this is finding the inverse.
I know, but like this is confusing.
Oh, crap. Well,
But
we're just solving for x. Not just. Just is a... I don't mean just. We're solving for x right here. We need to get x by itself. That's what we're doing. Somebody earlier already gave us a couple steps to do it. That's why we're just copying what they did. So like, didn't we do something similar, but a little? We actually did a slightly harder thing last time. We're just following the same kind of steps.
so this goes for all inverse problems. Whenever you find the inverse first.
Get rid of the fraction first. Fractions are ugly. Nobody likes fractions. Get rid of the fraction. Yes, that for all inverses that are fractions, undo the fraction first. And then usually there's a distribute to be done. Most times. And then there's what? Yeah, let's get rid of, we're trying to get x by itself, right?
I mean,
No, we already had y. Don't redistribute y. That would get us back to the step right above. No, that would get us to the step right above.
oh.
If we took out y, look right above it.
Divide by
Let's get x by itself. 1 plus 2y. Right?
Oh, okay.
And now we're one step away. What's the next thing we should do? Divide by y. Divide by y. You've got x equals 1 plus 2y over y. And now what was the last step? Karen, you said it earlier. Switch x and y. Yep. You can do it at the end if you want to. Like I've taught it in college algebra where the book said do it at the very end, solve for x, and this book said switch them and then do it. And I don't. You just have to remember at some point you got to switch them. Y equals 1 plus 2x over x, and then.
So at this point, before you get to the green, you were still solving for x. And then once you got x by itself, then you
Switch x and y.
okay.
Wait, that doesn't look like that.
Why would you have 2x over x?
What's your question? Yeah.
On the last question, the one that we did before,
Mhm.
similar to this, I thought we were supposed to switch. Where's the x become the y?
Where does the x become the y? Right here. This is where it happened. That's the step where we switched them. That red line is our switch step.
Oh, so we're not gonna switch.
You can switch it earlier.
Oh.
You can do it earlier. I think the note said do it at the end, and I was like, oh crap, we switched it. Somebody, I think it was Rick. Somebody said switch them right away. It might not have been. I don't remember who it was. Somebody said switch them right away. I'm just showing you. It doesn't matter when you switch them, just that at some point you switch them. I'm not gonna force you switch them at the beginning and then solve for x, or that would be solving for y. I don't remember what the notes exactly said. There were 4 steps. One of the 4 steps better be switch x and y. We did it at the end. Sue me. But I have a bigger problem than that. That's not this. Bless you.
That isn't then.
Right?
It's kind of weird.
Anybody got any ideas?
Maybe it's because
Think about a pizza.
you can get rid of the. Yeah, you can get rid of the x by the 2. Right?
Yeah, somehow. Think about a pizza. If you have 2 pieces of pizza and I have 3 pieces of pizza, what is the bottom of that pizza? If we got a pizza with 8 pieces, right? You're the blue person. How many pieces do you have?
5.
2 out of what?
8,
I'm the red person. How many pieces do I have?
1.
What's the answer to that question? How many pieces do we have totally? Is that an okay thing, whatever just happened there? Is that the same thing as this? Because look, 2 plus 1 is just 3, right? So fractions can be added and subtracted as long as the bottom stays the same. So what does that mean that x can do?
Add
1 over x plus 2x over x. What happens to one of those x's? Yes. Or it turns into 1. I know, you're right. No, you're right for math's sake, but those 2 x's turn into 1, right? And now we've got the same thing. This is actually seemingly, out of everything we've done today, I am hopping over to inverses, and I'll grab the easy ones too. CUDA, inverses. Before you leave, I'll mark everybody here today, even if you weren't here. This is a darn good practice for that. Here's 8 new problems. I'm just going to post them right to the same thing. So if you want to practice that type of problem.
Was it in inverse?
Yeah. Look at that. That was the same thing. Look, I copied and pasted that, and those are the same. So here's, I'm putting on a bunch more inverses since that seemed to be the hardest thing we did. You are welcome to stay through 2 o'clock if you want to. You're welcome to go. I just don't want you to feel like you can't review if you need to. Have a good day. I'll mark everybody here. What's up?
Oh, you're gonna mark everyone here?
I'm just going to mark everybody here today. That way we can.
That'll be perfect. Thank you.
Okay. Do you know the number of it?
Quiz number 4 for me.
Yes. On Friday.
On Friday.
Last Friday.
Last Friday's quiz.
And Mr.
Okay.
Cohen?
I'm going to print it and send you to go grab it off my printer.
Oh, I need
But give
to
me-
take a quiz too.
Okay. Wait 1 second. We'll do it right now. Yes. What's up?
Oh, I definitely don't know.
What's up?
You might start posting the handouts on, or do you do it and I just do it? Like the extra handouts, like the lab thingies and.
Oh, no, I never do that because those are all just made up on the spot. But I should, and I will. Yeah, I'll start doing it. I don't.
Like
Well,
when I missed lab,
but like we
I-
didn't have a handout for like the parabola lab. I was just like, do it and send me a picture. So because it cut
Parabola lab? Which one?
like random stuff. Sometimes it's just random. But yeah, I can try. I'll try to start being better about like typing up a description. But sometimes I'll just leave, like we'll be in the middle of class, like with the parabola thing where we threw a tennis ball.
Mhm.
I just literally in the middle of class was like, oh, this would be a good lab. Let's go do this, and we just did it. So I didn't have a handout per se. but I will. If you miss something, we'll figure it out. Don't stress. And I can type up a thing that's new, and we can do it, even if it's a little later.
I will go on.
Okay.
Yeah.
1 second. I'll get quizzes. Yeah.
Are you getting my emails if I will mark myself absent?
Yeah, I'm marking you present. Yeah.
Okay. Yeah.
I'm marking. No, I know.
Sure that you were getting
No, I'm marking you present.
Okay.
Yeah.
Darn it, I was right. Why did I cross it out?
Okay. What's your question?
My question was with the inverse thing. Like,
Mm-hmm.
why did you were saying you didn't switch around the Y on before?
Yeah, but you can.